sometime later. There's the second one done. As far as I can see, I've done everything right, but I'm going to buzz it out anyway, just to make sure, because it's getting towards the end of the day and my energy reserves are very limited, and yeah, I start getting tired. But I think everything is okay. The heater wiring was less straightforward here. This is our sort of heater wiring coming in from outside, as it were, from the power supply. And the wires here were shorter because obviously our valve base, as mentioned earlier, is sort of twisted anti-clockwise. So they're not twisted, but to save like unsoldering that, putting new wires in, finding some wire that matches that, blah blah blah. Let's get the bugger done, tick tock and all that. And so next we'll tackle the other two. The other two valve bases I don't think are as bad as the ones over here. However, I've got new valve bases, yeah, needs doing, so I'll crack on with that. More later. A bit of added fun. I've had to take the fascia plate off and all the knobs, and that is just to be able to get at this. I bet you can't see, there's a little screw right down there, and I can't get at it with that. Sort of moving that, and it looks like, well, we'll see, I might be able to just scoosh it aside a little bit. But interestingly, let's get a bit of packing. Interestingly, you can see we've got the legend of all the controls here on this faceplate, and as you can also see, some of this white, I think, is from this fascia plate. Have we got anything else interesting there? No. One thing that the owner was sort of not concerned about, but had a question about, was this here. Ah, okay. Was that there, which I've just made worse, which is from the other units that I've seen that would have had sterns there in that little window, and that's the sort of on light there, and yeah, that's not there. And alright, I'm going to pick that up. I was going to try and pick it up. I'm going to need tweezers for that. It's very, very fragile. So yeah, that would have had sterns on it. But as he correctly surmised, the heat from the little lamp has over time, yeah, it's just knackered the little label. However, somebody with a printer and all the rest of it could quite easily replicate that. A job for Mend It Mark. One other thing that I noticed, we've got bass and we've got treble there, so I think this is letraset. For those of you not old enough to know, back in the day, if you wanted to label something like this, you used to get like a transfer sheet, transfers we call them in England. I think in America you call them decals. So you got a transfer sheet, and if you rub them, then it would put the letters on. Obviously somebody's put an extra R on there. I'm not going to clean that up or mess about with it, because it's a bit of nice interesting history. Yeah, and you can see where somebody originally has also put like some gold paint behind, Whether that was because they screwed up with the lettering, I do not know, because Letraset is a bugger to put on. I mean, how the hell do you get every letter which you have to put on individually to go all in line? Yeah, not easy, and I've used it myself. Unfortunately, Letraset are no more. Gone. All you can get is like very expensive partially used sheets on Etsy and eBay. You know, you're talking like sometimes 20 quid for a used bloody sheet. And of course all the vowels, is it a vowel? Yeah, using the B's, A-E-I-O-U. Yeah, they're usually missing. Anyway, I shall stop waffling and crack on. Right, end of day, whatever it is. Sorry, got valve base number 3 in, mostly connected up. Got that one to do and to tidy up. Yeah, I think we're about there. Obviously, yeah, I've mentioned that, so really knackered. A few other bits to sort out, but that's mostly there. Wiring improved, bit of lead dressing and everything. We've got the leads aren't as nicely dressed as they could be, but I've left them long on purpose just in case I have to move them, because like when I get this tired I make mistakes and fuck up. So I'm going to call it quits there, have a few beers, a nice big spliff. Well, I don't know, not a nice big spliff, a little tiny one. Get me dinner and come at it fresh tomorrow. See you all later. To get the screws down into that hole is a bit of a nightmare, but luckily I have this little Ishkamoffit that helps. So your screwdriver goes in there thusly. Just get your screw, and that sort of grips that like that, and that holds that like that, and then we pop that in thusly, and it really aids in fabricating and all the rest of it, and getting into really hard to get holes and all that. I've no idea what you call the things, and I can't remember where they came from, but yeah, they're invaluable. Usually, I mean, I use these sort of spring-loaded, what do you call it? What are they called? Pincers? I don't know. Sorry, my brain fails me at the moment. But they have this nasty habit, because they're spring-loaded, of sending the bit you're trying to get into space somewhere, which can be immense fun trying to find little tiny washers and all that sort of thing. Luckily, the bloke who built this didn't put washers on there, and it's held together so far for about 4 or 5 decades, so I'm fine with that. Well, that's all the 4 valve bases replaced, rewired. Hopefully I haven't made any mistakes. Everything, as far as I know, is where it should be. I haven't made any mistakes, but even though I've been over it once already, I shall go through it again. Obviously these mica molds to replace before I can power it up AC wise, and then there are a couple of wax capacitors. Oh no, probably, Jesus fuck. Yeah, they're gonna be an absolute fucking nightmare to get at. Yeah, there's these wax capacitors down here. I mean, I could just leave them, but no, they've got to come out. They'll probably be leaking like a fucking sieve. These ones I can get to okay, but we'll see. I've managed to do everything so far, including getting at the little screws down there, however I couldn't fit the last one in right down there. I had to go at it about 5 times, and then yeah, sometimes you just have to get it best. Like, right, I shall crack on, and then hopefully when the rain stops I shall show you something really gruesome. That, yeah, anyway, I'll leave that surprise till later. Somewhere in this garden is a rat's nest. I've been waiting for the rain to stop, but it didn't go, and I've had to set a trap because I've noticed lots of little baby rats running about. We're on wobble cam. Check this out. So obviously the trap caught a rat earlier on, and then when I came out to check the trap because I heard it go off, there was a couple of its brethren, its litter mates, eating the fucker. Jesus, nature red in tooth and claw, eh? Why waste a good meal? Anyway, I shall reset that and dispose of the body. Have you ever gone for a walk and thought the ground in front of you looks lovely green and very firm? Next minute your shoes come off and you're up to your ankle, well, up to your kneecaps, like in gack. This is the point where I'm at the moment. So having replaced all the valve bases, I was about to move on to this McGubbins here. As mentioned previously, I can't remember what video it was, I think in the last one I run you through the circuit briefly. So we've got 5 inputs: auxiliary, radio, tape, magnetic and crystal or ceramic pickup. The first 3, well no, the first 2, auxiliary and radio, pretty straightforward. There's no really sort of tone shaping as such. However, the subsequent other 3, the tape, the magnetic and the ceramic or crystal pickup, have feedback fed back to this first EF86, and that shapes your response, your RIAA curve, in the case of the magnetic pickup. As far as I know, the chap I'm doing this for is really only interested in the magnetic pickup. However, therein lies a bleeding can of worms. These capacitors, as far as I can tell, are the ones concerned with the magnetic pickup RIAA response, as is this other one that sort of come loose and this one down here. However, if you can see down there, which you probably can't, there is, should I say, a wax capacitor and a airy resistor there and there that also forms part of the RIAA blah 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 tone shaping response. To get at them, to replace them, if indeed they need replacing, I'm going to have to take the whole thing apart. Lots of little nuts and bolts, etc. A hell of a lot of work. Also, I don't know whether, even when I've done this and replaced the capacitors and all that, whether it will have a good response. So where the hell do you go? What, you know, who do you get in touch with? Who do you turn to? I mean, fuck's sake. Yeah, that was a googly I didn't see coming. That was a curveball that I didn't see coming, and I should have thought about that, but never mind. So at the moment, I don't know where to go from here really, and the best way forward. I've taken out a few capacitors, resistors. So these are wax capacitors, and for those who And for those of you who don't know what these are old style capacitors, and they have a wax coating that hopefully protects the capacitor from moisture ingress. However, over a period of time, moisture gets in and alters the capacitance and probably the leakage, the current leakage as it were. These are 225 picofarads. However, in the Stearns literature and in the Mullard, original Mullard design, there are no 225 picofarad capacitors. These are also 2% capacitors. However, these are part of the ceramic response as far as I can see. This little one is part of the magnetic pickup, sort of RIAA, I get fed up with saying that, blah blah blah, circuit, 560 picofarads, and it looks like 5 picofarads. However, any of you who know about this sort of thing, to get like a correct response, sorry you can't see, to get like a correct response, you need to measure all the things with a reliable bit of test gear to make sure that the value of the actual component that you use in its construction is bang on. I have a Marconi TF 2700 Weinbridge, whatever you call it, measuring device. It measures capacitance, inductance and resistance, so no problem there. As mentioned, the problem is getting at the thing. Also, although I've cleaned these wafers, these switch wafers, I can't guarantee that there is good contact between the RCA etc. and going forward to the first input stage. So I need to have a think about this and see where I'm going to go forward, because if I'm going to replace this little capacitor here, which are down there, sorry you can't see, I'm also going to need to replace those. Fucking nightmare. I have to have a sit down and a cigarette and a think about this one. Well, I bit the bullet and took the side panel off. It wasn't too bad, to be honest. There was no horrible bolts that needed a crowbar and a 6-foot monkey wrench, and that means that I can get and service properly. That means I can get to and service this switch here properly. I'll zoom you in. Hopefully you can see, I'll frame you a bit better. Hopefully you can see there's a bit of oxidation, verdigris on the switches, although the switch contacts themselves may be okay. But the main thing I'm concerned about is these big high value airy resistors. Airy resistors like this, the ceramic ones. Let me try and find one without moving this about too much. That's an airy, oh shit, you can't see. That's an airy resistor. As mentioned, it's a ceramic tube with a carbon comp resistor in the middle, and they're known for going high value. Over time, and with say a anode resistor or something, it probably doesn't matter that much, but when we're talking AC and RIAA compensation, then it does matter, because the closer to the values that you want, that you can get, so most people use like 1% or even higher, resistors and capacitors for this job, then your equalization will respond better to the RIAA curve. God, that's a gobful. I'm just taking a load of pictures of the switch and the contacts because I'm measuring all the resistors, and to measure the resistors properly out of circuit I have to disconnect them, and what I don't want to do is connect them in the wrong place. That's just gonna make my job loads harder. So if you're mucking about with something like this, before you even start, take loads of pictures, which I forgot to do in the first place. Right, I've replaced a lot of the input resistors. Most of them are 1 meg. And so what have we got at the top? That's your AUX, that's your radio, tape. This is our mag. This is the one we need to figure out what we need, and this is our crystal. However, I mean, I can't see the chap having a crystal pickup, so maybe we could actually turn that into an alternative magnetic pickup. That's a idea for another day. Can't do the magnetic pickup replacement of the resistor there. There's a load more components as well that need changing. As I can't really do a great deal here at the moment, I think I'm gonna knock up a little circuit and give it a whirl. This morning I'm working on this, on breadboarding this little circuit here. It's just a very simple MOSFET follower, not a MOSFET follower, sorry, an emitter follower. Can you see that? Like that. This, however, these values are wrong. I'll show you why in a minute. The reason I'm making this is because, as mentioned quite a few times in the past, when in other episodes, the preamplifier has no cathode follower out. As putting another valve in would be a lot of work and a lot of mucking about, I thought about using the 12 volts that we got from the power supply, or 15 volts, whichever we want, because I've got an extra pin potentially on the power out lead umbilical. Why not use that 12-15 volts or whatever it is to make a little emitter follower, which will drive the output from the preamplifier into our power amplifier a lot better. If you don't have a good output impedance, you can lose high frequency response. So what have we got? We've got a BD139, few resistors, as you saw, very simple. Let's power it up. So as you can see, we've got a, just turn the intensity up a tad, we've got a sine wave on the oscilloscope. At the moment I've got 1 volt RMS going in, and I've got the 0.24 coming out, so about 250 millivolts RMS out, which obviously is shite, but we always get less out of a cathode emitter source follower, less than unity gain, as they say. I know why that is, well, I'm pretty damn certain to know why that is. At the moment I've just sort of been playing around with it, so there's a pot there just to set the bias on the BD139. Regarding THD, it's 0.4%, so could be better, but I think that a lot of that is due to the input impedance. Right, let's go and have a look at the circuit again and swap some components.